Hi everyone, this lesson is about solving simultaneous equations, and the process or the method we're going to use today is the elimination method. Now this method is perfect if we have a situation like the one I've got here. Notice when we look at the first equation, there's 4 times x plus 3 times y, and in the second equation, 2 times x, that's different, but minus 3 times y. Now here's the thing, when you see something like this, you've got equal but opposite. So the y pronumeral is positive 3 in the first equation, negative 3 in the second. Then we can eliminate by just adding these equations together. So let's go. We add downwards. 4x plus 2x equals 6x. Now, positive 3y added to negative 3y is nothing. It completely disappears. It's eliminated. That's the reason for the name. And then 29 plus 1 equals 30. So that's a very straightforward problem now. We just divide through by 6 to get the answer that x equals 5. In order to find the y value, we'll have to substitute back into one of the equations that we've been given. It doesn't matter which. I might choose to work with equation 2 because the coefficients are a little bit smaller, makes it a bit easier. So I will write from equation number 2. So I will rewrite equation 2. It says 2 times x, but I now know that x is 5 minus 3 times y equals 1. So negative 3 times y can stay where it is. The 1 can stay where it is. Now 2 5s are 10, and that's a positive 10. If I transpose, it will be subtract 10. I have negative 3 times y equals negative 9. Dividing by negative 3 gives the answer positive 3. So my solution then for x and y, I have x was 5 and y is 3. X is 5 and y is 3. That's my simultaneous solution. Those numbers, 5 and 3, will make both of the equations true. To illustrate that, I'm going to bring over my GeoGebra. Here we are. So I've set up the first equation here, and there's the first equation. It's just labeled equation 1, and I can have a point somewhere on that line. Where did it go? There it is down there. Now that point B is fixed to the line, and as I drag this along, any place I stop, that value for x and that value for y would make the equation true. So there's, who knows, there's an endless supply of these numbers that would work. So let's just leave that somewhere here where it's easy to find. Now let's have a look at equation number 2. There's equation number 2, and I've also got a point fixed onto that line there. So this point A, anywhere I go along this line, there's a set of numbers. So 2 for x and 1 for y would make this equation true because it's fixed onto there. If I go a bit further, then that's an interesting point. That same point exists on both lines, the value 5, 3. And that's because that's the intersection of the lines. That coordinate 5, 3 should look familiar because that coordinate was the solution to our equations. Okay, so we've seen two methods here today. We've seen the elimination method, which is an algebraic process, and we've seen the graphical method. So if I've got a nice computer plotting program like this, I could find the intersection point of the two lines. That intersection point, I could literally read the coordinates right from the graph to get the solution. Thanks for watching.